Hello, I'm Jo Colwell. I'm really excited that STFC is coordinating a slot at the AAAS for this year. We will be bringing a really exciting, innovative piece on green energy storage, and I hope that you'll be able to come.
My name's Bill David, and I'm one of the senior scientists here at the ICIS Neutron and Muon facility that's behind me. And it's one of the biggest facilities in the UK. I'm also, in fact, a professor of energy materials science at the University of Oxford.
So hello, my name is Professor Serena Cussen. I am the Head of Department of Materials Science and Engineering at the University of Sheffield.
Hello, my name is Dr. Alexandr Simonov. I work at Monash University on the global challenge of converting renewables into their fuels and useful chemicals.
Here at Harwell and at ICIS, we really are at the crossroads, not just of UK science, not just European science, but world science. We have people coming from across the planet, from the United States, from Japan, from Europe, from South Africa, from Australia, and so it is very much a crossroads. So there's a huge cross-section of people, and of course, they're here, and they end up talking to each other, and there's many collaborations like that have developed where people who've got that interest in science, a common idea, or sometimes actually a complementary set of ideas, can come and work here and do some fantastic science in world-leading facilities supported by world-leading scientists and engineers.
Material science and engineering is like the perfect subject to be in to start to try to unpick some of these challenges that face battery materials, because it sits at the interface of chemistry, physics, engineering, mathematics. So once we've identified a synthetic route that we think looks promising, and it's given us a material that has some performance characteristics that would be indicative of great promise, we would head along to the ICIS Neutron and Muon facility to try to understand, well, what is the structure of that material? And looking at things like the actual performance of these materials, we make great use of the Muon facilities available at ICIS. And then all of that information that we glean from these really state-of-the-art experiments that we do at central facilities, it then all feeds back into our design process. What have we learned from those structural and dynamic characterizations, and how do we use that then to make even better materials for the future?
We are in particular working on the generation of hydrogen and ammonia in the technologies which we call green. Green because we only use renewable energy to power them, and we only use air and water to generate our final products. Batteries and the electrosynthesized fuels should not be considered as competitors. Among the green fuels, there are also different options, including hydrogen, ammonia, and carbon dioxide reduction products. And each of them will have their own application niche in the future, including the long-term storage or the long-distance transportation.
We'll be discussing all of these challenges on storing clean energy, the key to a zero-carbon future, at the AAAS conference on Friday, 3rd of March. See you then.